Hello guys, welcome to my channel. It's been a while since my last video and I finally managed to put it together. The purpose of the video is to show how to use DeepSeek's API in Python. In particular, we will try out the DeepSeek Reasoner model and see how to perform an interactive conversation with DeepSeek in Python. Without further ado, let's get started. Before we can use an API provided by DeepSeek, we have to top up the balance on our account. Luckily, this is easy to do, and we need to sign in at platform.deepseek.com. Then we can click the Top Up tab. There are two currency options, US dollar or Chinese yuan. For US dollar, we can use either a credit card or PayPal. For Chinese yuan, we can use Alipay or WeChat Pay. I personally prefer WeChat Pay. By all means, choose a payment method that suits you best. After topping up, we can click the Billing tab to check the status and see success. Before we start coding anything, let's have a quick look at the DeepSeek documentation to get a sense of what is required in our Python code to interact with DeepSeek properly. If we go to apidocs.deepseek.com and click Reasoning Model, this model would use the so-called chain of thought methodology to improve accuracy. What that means is that, instead of providing an immediate response, the model would generate a step-by-step logical analysis of a problem before arriving at a final response. This approach arguably makes AI decisions more transparent and reliable. Note that DeepSeek's reasoning model allows users to access the contents of its chain of thought, and we will see later in this video. DeepSeek's reasoning model also supports multi-round conversations, meaning that we can encourage DeepSeek to ask us questions to help it clarify all the essential contexts and backgrounds before giving a response to our question. Put simply, DeepSeek can aggregate all our conversations, use its chain of thought capability to analyze them, and then give a highly pertinent answer. If we scroll down further, we can see the basic Python code structure for interacting with DeepSeek. We can mimic this code and build a simple function to get a sense of how to interact with DeepSeek. What we're going to do is wrap this DeepSeek API call into a Python function to make asking a question a bit more user-friendly. So in our function, there are a few parameters we could specify for our DeepSeek API call. First off, the name of the model we are using is DeepSeek Reasoner here, and by all means, try out another model such as DeepSeek R1. Then comes the actual message that we would send to DeepSeek. Note that here we make this message's parameter dynamic, which means that every time we make an API call to DeepSeek, we can type a new message in the call, like this. Then we have temperature for controlling how creative the model can get. A value of 0 denies creativity and elicits as many facts from the model as possible. Max tokens specifies the maximum number of tokens that are going to be returned in response by DeepSeek. Let's give this return response function a try, and we are going to ask DeepSeek for the 5 greatest NBA players of all time. Let's run this. The output format looks messy. But if we go directly to choices at the 0 position, then to content under message, we will get a much better output format. Let's run this. You may wonder how I figured out this quick way of extracting the output content. Well, it's in the DeepSeek documentation, which is here. Now, we can enhance this return response function into a chatbot that remembers all conversations, so it can reference conversation history before answering a question. To achieve this in Python, we will make use of a programming tool called class. A Python class is an efficient way to organize code so that a real-world object can be mimicked in a program. An easy way to understand this is to think of a Python class as a basic recipe or blueprint for simulating a real-world object in a programming environment. For this programming recipe to work correctly, programmers must define two components, attributes and methods. Attributes are essential facts or data that describe the key characteristics of a real-world object. Attributes of a Python class can be designed to be dynamic, meaning that when we instantiate an object, its attributes are going to be unique to that specific object. Take this car as an example. Some of its attributes include color, size, brand name, etc. Different cars will have various colors and sizes. Methods, on the other hand, are functions that an object can perform. In our car example, the car can, at least theoretically, move forward, turn left or right, or stop moving. And these little actions or functionalities can all be defined as methods in a Python class. If we switch back to our chatbot, one superpower we want it to possess is the ability to maintain conversation history across different runs of conversations within an entire session. So here we have this messages attribute, which serves as a container for all conversations between users and DeepSeek. Note that this self-parameter refers to an object or instance of this chatbot class. This implies we can create or instantiate as many objects as we like from this chatbot class. When we say creating or instantiating an object from a Python class, we mean this. Here, there are 4 different chatbot objects, all created from the chatbot class. We can do other things with each of the 4 bot objects. For example, we can ask bot number 1, who is the President of the United States? Let's run this. We can also ask bot number 3 who the wealthiest person in the world is. However, in reality, we may not need to create that many objects from the same Python class. Here, we are trying to grasp an important but not easily understood relationship between an object and a class in Python. Let's move back up to our chatbot class. This init function, which means initiation, automatically creates any attributes defined underneath and assigns them to an object created or instantiated from a Python class. Here, in our chatbot class, the contents of the system prompt are automatically stored in the messages attribute whenever a chatbot object is created from this chatbot class. To be clear, this init function will automatically assign whatever attributes are defined underneath to an object created from a Python class. So if we scroll back down a little bit, all these 4 chatbot objects each have their own messages attribute, all pointing to the same system prompt demo parameter in our demonstration. As a side note, each chatbot object can have its own system prompt for driving different behaviors. This is certainly something you can try out on your own as an exercise. Below the init function is this query function, which is an example of the methods component of a Python class we mentioned earlier. This query function literally lets us make queries and send them to DeepSeek. However, technically, this query function performs a few subtle actions behind the scenes. Firstly, note that this query has the self parameter in it, meaning the query function will be automatically created whenever we instantiate a chatbot object from this chatbot class. Secondly, we can see that the query utilizes another attribute called prompt. This prompt attribute will temporarily store the contents of a prompt in the current conversation. Thirdly, this prompt is automatically appended to the messages attribute that we saw earlier. So every time a user makes a prompt, it will get combined with the messages attribute, which, because of this automatic appending routine, would contain the history of previous prompts at any given point. Fourthly, the query function will pass the messages attribute to DeepSeek and get a response via the return response function we defined earlier. However, as we saw earlier, the full output from DeepSeek's response can be challenging to read. So here we can extract the exact contents of the response, along with the reasoning, for easy reading. As a side note, the reasoning behind a DeepSeek response helps us understand its logic. Finally, the contents of the response will also be appended to the messages attribute, so that in the next prompt, DeepSeek will have the full context, including the responses it gave in previous conversations, before responding to the new prompt. At the bottom part of this query function, we have a few print functions to make the output easy to read. The function will first display a response, followed by a blank line and a marker separating the response from the reasoning contents. It will then show the reasoning contents of a corresponding response. For the rest of this video, we will continue using this chatbot class, but with a specific purpose. We will assume the role of a data analyst in the hospitality industry and seek advice from DeepSeek on how to prepare ourselves for a better future and stay relevant in this career, we would allow DeepSeek to ask us questions in a back and forth conversation, one question at a time, until it has enough context about our backgrounds and skill sets to make a more pertinent recommendation. To ensure DeepSeek aligns with our expectations, we can use the so-called system prompt, which can control context awareness and shape an LLM's response style. Here is our system prompt, essentially stating that we are trying to determine the AI skills a data analyst would need to develop, and asking DeepSeek to ask us questions to gain enough context to make pertinent recommendations. Let's run this and also run this, then we can instantiate another bot for the rest of this video. Our main question is stored in the main question parameter, and we want DeepSeek to recommend relevant AI skills for us to develop in our data analyst career to stay competitive in the hospitality industry over the next 5 years. Let's run the query function for our main question. Okay, we have got a response from DeepSeek. It needs to understand the primary job responsibilities of a data analyst in the hospitality industry. Right below DeepSeek's response is its reasoning, which shows its chain of thoughts and why it would need to ask us specific questions. Feel free to stop the video and read all this, but essentially DeepSeek is saying that the job responsibilities will provide insights into the daily tasks a data analyst would handle and help it gauge where AI can augment rather than replace human strengths. To follow up with DeepSeek, we can describe the job responsibilities of a data analyst in the follow-up question 1 parameter. Here, we essentially say we help our employers become more profitable by identifying profitable business segments and better ways to allocate resources. Let's run the query function for our first follow-up question. Now we get another response from DeepSeek. This time, DeepSeek needs to know which specific tools we use in our jobs as data analysts. Again, right below DeepSeek's response is its reasoning. Feel free to pause the video and have a look at the details of DeepSeek's chain of thoughts in this step. To continue our follow-up with DeepSeek, we can provide a brief description of the tools we use in our work, as contained in the follow-up question 2 parameter. We are telling DeepSeek that we mainly use Python, SQL, Tableau, and Excel. Let's run the query function for our second follow-up question. Now we get a third response from DeepSeek. This time, DeepSeek needs to understand how experienced we are in machine learning and predictive analysis. Again, feel free to read DeepSeek's chain of thoughts in this response. In this follow-up question 3 parameter, we tell DeepSeek that we have occasionally built machine learning models. Let's run the query function for our third follow-up question. Now we get a fourth response from DeepSeek, which asks about the types of data we usually work with and whether we have dealt with unstructured data, such as customer reviews. In this follow-up question 4 parameter, we tell DeepSeek that we primarily work with transactional data. Let's run the query function for our fourth follow-up question. DeepSeek has finally collected enough information and made recommendations on 6 core skill sets we need to develop over the next 5 years. The first is advanced predictive modeling and machine learning. DeepSeek believes there will be occasions when analysts will be asked to build production-ready systems to predict customer demand, churn rates, or revenue trends. Machine learning models can handle forecasting and pattern detection with ease. The second one is natural language processing. DeepSeek mentioned that NLP can automate sentiment analysis of customer reviews, social media, or feedback, providing deeper insights into customer preferences and strategic positioning. The third is data engineering. DeepSeek argues that data engineering skills enable analysts to handle a variety of data at scale and to deploy models efficiently in environments with ever-growing data volumes. The fourth one is AI-powered optimization and decision science. DeepSeek believes that optimization and decision science can help organizations make better decisions for resource allocations, operational efficiency, and revenue management. The rationale is to imagine that the effectiveness of optimization and decision science techniques can be further compounded by the use of AI. The sky is the only limit. The fifth one is about ethical AI and explainability. DeepSeek argues that it is crucial to promote model transparency and explain predictions to stakeholders. Analysts should therefore learn techniques for model interpretability and stay updated on AI ethics guidelines and data privacy regulations. The sixth one is domain-specific AI applications. DeepSeek believes that there will be situations where analysts will need to build their own hospitality-specific AI tools or models, such as applications that incorporate recommendation engines or pricing algorithms. It is therefore becoming increasingly important for analysts to cultivate a developer mindset. As part of the recommendations, DeepSeek also provides an implementation plan for learning all these skills. In the first year, analysts should strengthen their Python and SQL skills with a focus on ML libraries. In the second and third years, analysts should dive into NLP and data engineering. From the third year onwards, analysts should start mastering machine learning operations. This is everything I have prepared for this video. I hope you have found it helpful. Certainly, DeepSeek has given us many valuable recommendations. Still, I would like to argue that AI technology has evolved so quickly that we need to regularly review our skill development as well as the ever-evolving AI capabilities. So specific nitty-gritty in data analytics may become even less important when AI becomes increasingly powerful and user-friendly at an exponential rate. Alright, I'll see you in the next video. Until then, stay happy and healthy.